Hello, hello. Thank you. Welcome to Cisco's fourth and final session of the day. And thank you for dropping by. I'm going to quickly introduce our next presentation and presenters. The presentation, obviously moving to the edge with NFV, is going to be presented by Narendra, one of our senior product managers at Cisco, and Jeffrey Salins, principal engineer at Charter Communications. And I'm going to turn it over to them, and we'd like to save the best for last.
All right. Thank you, Gary. Good morning, folks. Almost afternoon, and we are the only thing between you and lunch. That's always good to know. No pressure. All right. Thank you for being here. Hope you're all doing well. So what we're going to talk about today is NFV, move of NFV towards the edge. What is the edge? Where is the edge? Can we find it? As well as what is the operator's point of view of deploying cloudlets across a massive scalable footprint across a service provider. So my name is Narendra. This is the ETSI NFV reference architecture. We are all very familiar with this, the Bible for all of us who are in the world of NFV. Just want to set it up for you in terms of some terminologies and what we're going to talk about, right? So it's right off the framework. Essentially, what we consider as NFVI is the physical hardware, the virtualized compute network storage, as well as the management of that physical infrastructure and virtualized compute network storage through a virtualized infrastructure manager, which happens to be OpenStack. So that entire red piece, pieces around the red box, is what we call as NFVI, or what we refer to as NFVI at Cisco. It's the totality of all the hardware and software components altogether. And the virtualized infrastructure manager based on OpenStack is the software platform, the glue that brings all the physical infrastructure together along with the virtualized compute network storage resources, manage them, lifecycle, manage them and such. On top, obviously, are the workloads, the SDN controller, the VNF manager, Mano pieces together. So how do we map this to what we have at Cisco, what we offer as a complete end-to-end stack, mapping to the ETSI NFV framework? At the bottom half of the slide is the NFV infrastructure. That Cisco NFV infrastructure consists of Cisco Virtualized Infrastructure Manager based on OpenStack, NFVI monitoring, unified management, SDN controller as an option, as well as the hardware pieces, obviously the server, network, and storage. At the VNFM layer is the Elastic Services Controller, and the orchestrator is NSO, Cisco NSO, powered by TAILF. So here's the Cisco NFV solution architecture. This is the sort of our footprint of anything and everything that we do at Cisco related to NFV, right? Again, it maps back to the ETSI framework. It maps back to the previous picture that you saw. So the NFV infrastructure consists of physical hardware, compute network storage. There is on the right-hand side at the bottom, you see something called Vim. That's Cisco Vim based on components from Red Hat. And that's the lifecycle manager that basically gives you that software platform on top of all the hardware infrastructure. Along with that is unified management, which can manage infrastructure across geographies, as well as monitoring and assurance capabilities. For programmability purposes, we have an API through which the infrastructure could be programmed, could be managed end-to-end through its entire life cycle. And the infrastructure, of course, is capable of supporting and onboarding any and all workloads, VNFs, be it Cisco, be it third party, be lifecycle managed by the VNFM, Cisco ESC, or any other interoperable lifecycle manager. And of course, the the NFVO, Network Function Virtualization Orchestration, and resource orchestration through NSO. All right. So what are some of the use cases, right? It's a single architecture, it's a single platform that delivers multiple capabilities, that's capable of onboarding, accommodating multiple different types of workloads and use cases. So what are those use cases? It could be as varied as business services, virtual managed services, VCPE, virtual branch, SD-WAN, as well as mobility, packet core, evolved packet data gateway, MME, IMS, you name it. Could be core routing services such as virtual PE, virtual BNG, media workloads, third-party VNFs, of course, so long as they are interoperable, compatible with OpenStack. So the key aspect is about this picture is, yes, one platform, multiple workloads. There's one and only one way, open standard way of interoperating with the platform. That is the standard OpenStack APIs. Right? There's no proprietary element. Any VNF manager can come in and talk to the same infrastructure through the OpenStack APIs, and any VNF could be onboarded so long as it's compatible with OpenStack versions or the package that we are running and such. Right? So there's no proprietary element involved at all. We also do this or bring this solution to the market with a key set of partners. Cisco, Red Hat, and Intel are a part of this partnership. Cisco is the lead in this partnership, bringing this entire platform together to the market, and also being the single point of support and single point of procurement. Now, so that's the fundamental pieces of the Cisco NFV solution, the infrastructure level details, and what we do on a day-to-day basis. Now, in terms of the evolution, right? So what we have seen, and this is a big topic across the summit this week, is NFV moving getting out of the data center or finding its new places beyond the data center into other places of the network in a provider's landscape. And that could be many different places. There are many reasons of why that is useful, why it needs to happen. So what it brings to us is a service instantiation that's pushed as close to the end subscriber as possible, that basically can handle much faster response times, end user experience can be enhanced, or in some cases there are some workloads that can be or some use cases that can be delivered only if we are as close to our subscribers as possible. And also, the edge data center pushes all the subscriber-facing processes, right, much closer, as well as better user experience, increased infosec and such. And there's many different ways to do this. We had the sort of the evolution is we had the backend data center going all the way to the subscriber. The next evolution was okay, move this to the front end data center, maybe like a regional data center and such. Now we are pushing it even further to a central office hub location types, where okay, so we are pushing it closer and closer, but what it also entails is that there is a challenge for footprint, there is a challenge for power, there is a challenge for cooling. So how do we take care of those challenges while still enabling NFV to sort of permeate into the provider's environment? So to talk about those aspects from a provider's point of view, from an operator's point of view, I welcome Jeffrey, who is the principal engineer at Charter Communications, to take us through the details of what they see from their eyes from the other side of the world. Thank you, Jeffrey.
All right, thanks, Naren. So, hello, everyone. I'm Jeffrey Salins. I work at Charter. I work with that fine group of gentlemen back there in the advanced commercial engineering team. We do architecture, we do design, we do development, and we cater to Charter's commercial consumers from E-lines, E-LANs, managed services, et cetera. So, service providers, what do we have that nobody else has? We have a really large footprint. We have the ability to push our services right into people's neighborhoods. We have hubs, head-ins, cell sites. So really kind of what differentiates us from, let's move everything to AWS is our access. not just access, but like really, really high-performing access when we start looking at PON, GPON, et cetera. So with this massive scale, though, comes the challenge of the scale itself. How do I manage all of this? How do I take advantage of it? And how do I intelligently place my workloads? NFV obviously has been like the hot topic for like the last several years. You have to ask yourself, though, what do I gain from virtualizing something? Can I solve this with a physical device at cost? What will I actually get from putting something in an NFV? A lot of times for us, it's about rolling a truck. Part of that scale, when I have to go out to every single location, means that one of our techs is going to have to get in one of those cool charter vans, says Spectrum on the side of it, drive out to a broom closet-sized data center, and start messing with cables and troubleshooting, right? Versus the whole herd versus cattle thing is, I'll just tear a VNF down, redeploy it. So when we build out our multi-service edge compute, we're asking ourselves, what's the trade-off between our operational cost and the complexity that we're now introducing into our network versus lower latency, a higher customer experience, and then possibly better traffic engineering. So I kind of map out the stuff at the top. I feel like that little linear diagram has been probably presented 30 times in the last 48 hours. But we're right now kind of looking more at like the head end. In an ideal world, I'd be able to do everything in Kubernetes and just add no more nodes as minions and distribute them. But the reality is I work at a cable company, and we probably still have gear from like 1988 running in some of our data centers. So I need a Vim that's going to support VMs, bare metal, and then hopefully eventually containers once those workloads start to transition. So, really the two big things, you got your colos, you've got your telcos, and you've got your cable providers. We come from the cable side. And so looking at like some of the access stuff, we'll talk about use cases later, but what happens when I start to take CMTS and virtualize it? Like, what do I gain from that? What kind of complexities do I add? And apparently there's a white paper now on what edge actually means. To me, it's kind of a meaningless buzzword. But in my mind, really, it's a service definition or a function, not necessarily a location. So the first thing we had to do is rethink our infrastructure. Since I don't live in this nirvana of Kubernetes solving world hunger at the moment, I need to be able to deploy this infrastructure in really, really tiny data centers. So on the left-hand side, it's a pretty standard deployment that we all know and love. You can go to openstack.org and see your 3 control nodes, your 3 storage nodes, and then your scaled-out compute, right? That doesn't work when your data center is the size of a coat closet, where every single RU is worth its weight in gold. Every bit of extra power that I have to run to that rack costs the ISP that much more money. So we start to bully our vendors and say, shrink this. And we came up with the micropod topology, which is on our right-hand side there. So moving into the edge architecture, we needed to figure out how we could get still a highly available OpenStack deployment with as little actual rack unit consumption as possible. And so what we did was we collapsed everything onto those 3 converged nodes. You've got OSD running your Ceph backend, giving you your redundant distributed storage. You've got all of your core control plane services running in containers on there. And then additionally, we run Nova Compute and Neutron Agent there so that we can spin VNFs on there. So you do have the ability to add more compute there, but at the bare minimum, I can host highly redundant VNFs in this location right now. Additionally, the top of rack. So most of the vendors we work with are network companies, and they want me to buy more, bigger, expensive boxes, and we're always telling them no, make it smaller, make it cheaper. So started looking at the ability to take a router that will switch or a switch that will route and collapse that functionality into a single box. Progressing even to the point where, since we already have all of this access out there on our edge, what if I just took a single line card and a chassis that's already there, and I terminated my WAN on top of that while still giving myself my redundant Tor functionality? So additionally, what does OpenStack provide me to actually stitch into my WAN? Can I use OpenStack APIs to connect my VNFs into my core? And the answer is yes. So a lot of really smart people and other service providers like AT&T, Comcast, Charter, et cetera, a lot of people have been working on the Neutron APIs for BGP VPN. Basically what that does is it allows you to create an object inside of Neutron and give it a route target. From there, I can take that object and I can stitch either a port, a neutron network, or a neutron router to that object and pull it into an L2 or an L3 VPN. So now I've got all these attributed pods, and I can, from an API perspective, stitch it straight into my WAN. So what does this look like? A couple things I need to do once I have got all this consolidated is actually figure out how the networking works. I rely on the smart people over in that corner for that part of it because I'm a platform guy. But what we do is we collapse the edge, and once again, we go to our vendors and we say, I need a non-proprietary redundancy control plane. So we use EVPN right now. And not only do I want to use EVPN, but I want you to, within the same control plane, stitch my WAN side, whether it's VPLS, pseudo-wire, L2 VPN, into my underlying Tor functionality. So I use multi-homing, active-active from a Tor perspective, and then I terminate my WAN right on top of these top-of-rack switches or those top-of-rack line cards. Additionally, I use stuff like provider networks to make all of my customers' individual networks directly routable and take advantage of things like BGP, EVPN, or VPN to then stitch those VNFs into the cloud. So what does this provide me? Once again, you have to ask yourself, why am I moving to the edge, right? As a service provider, we do backhaul. One of the places that vendors like to charge us a lot of money is on bandwidth and port density in my core network. So I have to ask myself, if I'm going to spend the time and investment to move all this stuff out to the edge, what do I gain from it? For me, one of the things that I can immediately do is have smarter traffic control and potentially take a lot of traffic out of my core MPLS network. Do I really need to stretch this across the backhaul, or can I just spit it out to one of our drains in an intelligent fashion? Additionally, it starts to open up things, since we do a lot of L2 VPN, of allowing me to do active-active VNFs in geographically diverse locations. So using something like an Anycast gateway on my top of racks, I can take an IP address that is shared across two physically differently located pods and load balance traffic across them. Additionally, I can have a complete pod failure, like ditch digger cuts the fiber line to my head end, my hub loses power, whatever, and if my VNF is supporting it, it'll just pick up the traffic, EVPN will redirect down into this pod, and I'm good to go. So as you can see, this is an L2 stretch. I won't get too much into the weeds on the networking itself. That's kind of a different topic. But basically, how do I start turning these challenges into advantages, right? I do things like take advantage of Manos architecture. I do a centrally located VNF, or NFVO, and then I do diversely located VNFM. So should I lose my upper layer control plane? I have independent autonomous control planes in every one of my pods and a VNFM to manage the workloads inside of it. So that way, I can continuously keep all services up. If I have to roll a truck, it shouldn't be like after an impact to my customer if I've built the right amount of redundancy in there. So access is one of our key advantages, right? We have all of these locations out there, and I can now start to think about how I want to intelligently place these workloads. So the fact of the matter is, though, is we have drains, right? We're going to aggregate all of this traffic. We're going to send it to one of our RDCs where we have one of our big drains into the internet. What I have the control of now, though, is deciding if I've got a customer who wants to buy a managed firewall from us, I can potentially decide, do they necessarily need to go all the way to one of these regional data centers, or can I put 2 pods in a market where they have 5 branch offices and then stitch it straight within them locally? Save 3 to 4 hops, give them better latency, et cetera. Additionally, what is going to be the next evolution of our content? As we start to move into mobility and look at CUPS architecture, as we start to look at new Internet of Things and AR, VR, all of a sudden geocaching becomes really, really important. So I don't know who else is a nerd and was like an Oculus DK1 purchaser, but I was. And I would get really, really, really sick every time I spent more than 5 minutes in my dev kit. 20 milliseconds is your cutoff before you start pitching your cookies in VR. And so for me to actually get a high-quality streaming content of VR, I need to make sure that I can put that content as close to my end consumer as possible. Without that, you're going to have a lot of sick, angry people trying to watch NASCAR in 3-dimensional VR, and Gordon's going to make that first turn, and the next thing you know, you're going to have very unhappy customers. Additionally, Internet of Things. If I've got smart cars out there that are driving themselves and they need to get snap updates, I probably don't want a whole lot of latency when that car decides whether or not it's going to run over the dog running across the street, right? So moving into this space, like I said, if you don't have a valid use case, you probably don't want to add this complexity and this cost into your infrastructure. But if you do have a valid use case, if you want to reduce the amount of backhaul traffic you have, if you want to provide a higher quality of service to your customers when they're streaming content, et cetera, then the shift to the edge might be a worthwhile investment of your time. So with that, I'm going to hand it back to Naren.
Thank you, Jeffrey. All right, so before we jump into this, it also, so extending to what Jeffrey said, we have to rethink the way clouds are deployed and the emphasis on whether it's the cloud or whether it's something else that actually makes the distributed workloads and infrastructure run. So what I mean by that is it actually highly available pod that never goes down? Is that what my emphasis should be as we move out of the data center and into the edge? Or is it that these clouds and cloudlets are actually almost like cattle, and if one goes down, never mind, that's fine. There is some other intelligence out there at many different levels that can actually take care of that downtime and reroute traffic or rebalance things across the network because of the massive footprint, and things just keep humming away without a hitch, right? That's the very important thing that we also need to think about when we architect, when we design these things. And the emphasis changes of where that high availability is, which entities will provide that high availability. So now, tuning this back into, where are the NFV deployments heading? So we've been talking about this. Just want to again highlight the fact that there are many places in the network, like Jeffrey showed us his view of things. There's the customer premises, there's access, there is CO, remote data centers, central data centers, co-location or peering endpoints, and then the cloud-hosted locations themselves. And for each of these things, we have almost covered all. From your right-hand side, we have covered things all the way up to the CO in terms of where our infrastructure can go and deploy NFV successfully in each of those locations. The next frontier would be the access and the customer premise. And there's other things happening at Cisco that's already tackling that from the left-hand side towards the right, starting from customer premise. And when we have this sort of varied footprint and also size, location, and all of those pieces together, one of the aspects that comes up is, okay, fine, so we need to go to all these places in the network and we need to deploy our virtualized infrastructure, virtualized capabilities in terms of network functions. Well, then how are we going to enable that? How can we realize that? One way is the evolution of the workloads, right? And driving that in a manner which used to be primarily bare metal based and virtual based at some point of time. We have evolved into running things in OpenStack as well as other virtualized platforms. This is already evolving into can we make it cloud native? Could it be containers running in bare metal, containers running in virtual machines? What makes sense? And as we move from your left-hand side to the right-hand side, again, we have to superimpose this on the footprint of the network itself, right? And then as the workloads evolve, that's not the only dimension here. How do we deploy those workloads in a seamless manner, whether it's tens of locations, hundreds of locations, thousands of locations? How do we even update those capabilities? If I have a software update, how do I do that in this virtualized world? What happens to availability? What happens to things going bad? How do I recover from things going bad when I've actually taken a maintenance window? And how do I ensure that my customers don't have any major impact in terms of downtime or quality and such things? And along with that, so segueing into that part of the places in the network, the infrastructure, there's the edge to central location, cloud hosted and such. So the footprint will vary, first of all, right? Double clicking on this a little bit, there could be a nano sort of a infrastructure, a micro kind of an infrastructure, a couple of racks of infrastructure, all the way to a massive data center. And okay, there's many different kinds of footprints here, as well as different types of servers, perhaps, different capabilities, different horsepower. But how do we now take this infrastructure and manage it through a single plane of management and orchestration, right? If I have to effect a software update, could it be consistent between a regional data center and an edge location, the quote-unquote edge location? Also, there's multiple options here in terms of orchestration as well as workload management. There is, Kubernetes, there's KVM, OpenStack, bare metal. How do we harmonize across all of these options? Yet, at the same time, when we have all these, when we are playing with multiple dimensions, the key aspect is, we need to ensure that the promise of virtualization, quote-unquote virtualization and cloud native, is still satisfied, which is performance should be maintained. It should be carrier class. We cannot compromise carrier class performance just because we are getting flexibility in terms of where we deploy things, how we deploy things now, right? Automation, you heard it from the previous session also. How do we automate things so that it's seamless, avoid human errors, and I can go at scale regardless of what sort of action I am taking. Lifecycle management of the entire infrastructure as well as the workloads and the use cases that they deliver. Okay, fine. Now let's talk a little bit beyond that. Is okay, we have different types of infrastructures, different places, different networking devices out there. How do we connect up all these things? Not just the connectivity plane or the boundary of the pods. It's also what's inside the pod. How do I connect a virtual machine or a workload that's sitting on one server in one location to another workload sitting in some other location? How do I enable end-to-end connectivity? And that connectivity, again, not just one instance of that. I have massive, massive amounts of these things across my infrastructure now. How do I orchestrate that connectivity? How do I change things? How do I adapt to the changes that are happening because of downtime, availability issues, and such? So it's quite a fun and dynamic thing to sort of indulge in for a few minutes, if you will, as well as operational aspects, right? So, okay, this is running fine. When everything is running fine, we're all happy, smiling, probably going to go have lunch. But when things start going red, what do we do, right? How do we troubleshoot? How do we collect information to, first of all, troubleshoot? Before going to troubleshooting mode, are there ways for me to monitor these things in a manner that I can do proactive troubleshooting so that things actually don't go red at all? I can manage things when they're green or amber, right? Okay, fine. So what about security? I'm deploying in so many places, so many different types of workloads. I want to be, master of networking. I want to connect everything up in the world because that's what is needed. But at the same time, how do I ensure that there is a secure, I'll call it the fabric of security across this entire environment? How do I ensure that my customers' workloads are not being hacked or not being sniffed into? There's a lot of these aspects that we need to think about while sort of realizing where Charter is going, as Jeffrey talked about, and many other customers. So it's going to be a fun time doing this in the next, in the coming time, essentially. All right. So again, with end-to-end control plane, data plane, and orchestration. So that was the presentation. Thank you, folks, for being here. And also, there's lots of other Cisco sessions going on this week. Just a list for your reference here. Check them out if they are today, tomorrow, and day after. Check out your YouTube, or check YouTube for all the recordings. Hope you folks have a great day and the rest of the summit. Thank you for being here. Right. Oh, Q&A. You can hold on for Q&A.
He's already thinking lunch.
Yeah.
Are there any questions? I think right there.
So where does ONAP fit into all this? Where does ONAP fit into all this?
It's yet another option for us. That's about it. So we are not saying there is a prescription here, there's something in, something out, right? It's the dimensions of what we need to deal with. And ONAP, ONF, all of the OCP, all of those pieces come into play here, essentially.
So there are no ONAP components in this architecture, though?
I wouldn't think in such a manner.
I mean, technically, ONAP is going to sit higher up in the stack, right? Like,
That's kind of what I'm asking.
Right. So I mean, we didn't really dive into the ETSI model other than that like initial slide, but I mean, orchestration would be at a higher level. And I mean, like you said, the APIs are the APIs. So I mean, whether you're in indirect mode or direct mode, that's on you. So you can have NFVO talk directly to the Vim, or you can have the VNFM do it for you. But I mean, there's nothing preventing you from putting anything up there. Cloudband, Ericsson, ONAP, OSM if you're on the other side of the ocean, and that's the open source flavor that you like to subscribe to. But I mean, really, it's on you deciding like, how do I want to manage the workloads that are inside of my infrastructure, right? So nothing preventing you. It would just be like, what do you want to install further in your stack? And then once again, when we start looking at those disparate networking models, and when you move to distributed cloud, now I've got to decide, where does my NFVO live? Do I put it central? Do I put it regional? Do I push it to the edge? I mean, you could make arguments in different directions on any of those, but really it's going to boil down to what's your use case and what's your failure tolerance.
Any other?
Now you get to go to lunch.
All right. Thank you, folks.
Thank you, everybody.